So, before we get into evolution and the meaning of evolution, there are a couple questions we need to answer. First up, I've got a population here, a population of ladybugs. But within any population, are there two individuals that are exactly the same? No. You can have individuals that are very similar and or very different, but no two individuals are exactly the same with the same exact genetic makeup as another individual. You can't have like identical twins, and yes, their genetic makeup is very similar, but over their lifespan they accumulate small differences. So no two individuals are exactly the same. So what makes an individual who they are? And if you remember back to biology, individuals' behavior and makeup, what they look like or how they behave, comes from their genes. And their genes are made up of different alleles. And you get one allele from dad and one allele from mom. You remember what these things are called? Yeah, those are Punnett squares. And Punnett squares are used to calculate the probability of what genetic makeup offspring will have from a given known genetic makeup from a mom and a dad. So here I've got mom and dad. Mom's got a homozygous dominant, 2 capital T's, and dad's got a homozygous recessive. And to figure out what the offspring have, you just bring the allele from mom together with the allele from dad. Because remember, you get one allele from mom, one allele from dad, and 2 alleles make a gene. So say these genes, we're looking at color. And we have different alleles within my population. You can have alleles for orange in color, yellow in color, and red in color. And depending on what color you are, depends on your allele sequence and what your parents' allele sequence was. So now we can look at what evolution is. And evolution is the change in allelic frequencies over generation. Remember, these alleles are the different parts of a gene that you get from mom and dad. So how can these allelic frequencies change? Well, what is the main goal of every living thing? The main goal for every living thing is to survive and reproduce. All behavior and all action can stem down to survival and reproduction. So within my population, we've already said that no two individuals are alike. Do you think that everybody is going to survive and reproduce the same? No. Individuals within that population differ in their survivability and reproduction rates. And this is what natural selection is. And natural selection is the driving force behind evolution. I'm going to bring my populations down here, but natural selection is the driving force behind evolution. And I'm going to give a scenario here on how this works. So we've got my population of ladybugs. And this population of ladybugs lives in an area where there are red flowers. And they like to consume these red flowers. Well, also within this population is a dragonfly. And if you can see within the picture, what's he eating? Oh yeah, those dragonfly love ladybugs. Now if I have these individuals living in this environment, which individuals within here do you think would be more successful at surviving? And why? Yeah, if you said the red color would do better within these red flowers because they would be able to camouflage and hide from the predator dragonfly, you're right. And over time, which individuals or gene are we going to see more frequent of? Yeah, we're going to see that allele for the red physical characteristic be more persistent and occur more often within this area and in this population because of the driving selection pressure of this dragonfly eating all the other orange and colors that they could easily see and eat. And this is what natural selection is. It's you have variation within your population. Not all individuals survive and reproduce the same, and individuals that fit in better with their environment or can work better with their environment tend to survive longer and or reproduce more than those individuals that cannot. And if they're surviving and reproducing more often, what will occur? They will have more offspring than those that cannot survive. Because remember, you can't reproduce if you can't survive. So if you're surviving long enough, you have a chance to reproduce more, therefore producing more offspring that have your alleles and genetic makeup that then hopefully will help them survive and reproduce more in that population. So you can see how this population here could change in the allelic frequencies over time with a selection pressure, a predator, in this environment. Those that are red survive and reproduce more than those that are orange, and over time you'll start to see more individuals of the red color, therefore changing the allelic frequency because they are red because of their alleles that they got from mom and dad. Now, is it only survivability that drives evolution? No. Here I've got a population of giraffe. And within this giraffe you can see there are different physical characteristics. And the reason why they look the way that they do is because of their genetic material and their different alleles that they got from mom and dad. Well, say within this population that the color here, the orangish color, was favored more by females than the other colors. So once again, I have variation within my population. Individuals with a certain allelic or genetic makeup are sexually favored more than other individuals. Therefore, if they're sexually favored more, what are you going to see more in the population? Yeah, you're going to see this orangish color appearing more because they're reproducing more, therefore producing more offspring with those allelic types and that physical characteristic of being orange. Therefore, those offspring will have more babies because that physical characteristic that they got from their parents has a benefit with finding a mate and reproducing. Therefore, you would see more and more over time of this physical characteristic stemming from the genetic characteristic. Therefore, evolution is the change in allelic frequencies over generation, and natural selection is the driving force behind evolution.